Hello, everybody. This is Dr. Linda Koenig, and this is Chapter 6 of Counseling Research. So we're going to jump right in here. The characteristics of a research study. To be considered a research study, we have to compare participants in the different groups. Sometimes we have one group and we're comparing participants against themselves, or we have multiple groups and we're comparing one group against another group. We have random assignment of participants to the treatment group. We have manipulation of an intervention and or treatment. We measure outcomes, and we control extraneous variables, or variables outside the study that can have an impact on the outcomes. So remember that in our treatment control groups, the dependent variable is the variable that we're measuring. The independent variable is the variable that we are manipulating and or selecting, depending on what type of research we're doing. If our participants receive some type of intervention, they could be in the treatment group or they could be in the control group. The intervention is the independent variable that is manipulated. All right, so we're going to talk about three different types of experimental design. Pre-experimental design, which is on this side of our table, quasi-experimental design, which is in the middle, and then true experimental design, which is on our far right. So when we talk about pre-experimental design, we're talking about a one-shot case design where it's a one-shot deal. We have one group pre-test and post-test. And the features, we manipulate the independent variable, we have limited control over the extraneous variable, and we are not randomizing the control group. So in quasi-experimental, we have a non-randomized block design. It is also a time series design, and its features include manipulation of the independent variable and the absence of either randomization or a control group. And then on the far right, our true experimental design. It is post-test only design. It can be a pre-test, post-test control group design. It can be a factorial design. It can be randomized block design or a crossover design. And the features, we are manipulating the independent variable. We have the presence of a control group, and we have randomization. So as we talk about this, if you look to your far left, pre-experimental design is the weakest form of research. In the middle, we have quasi-experimental. We have a little bit stronger research, but it's still not as strong as a true experimental design where we are controlling most of the factors that are going into that. So we're going to look at different specific types that fall under these particular three groups. All right, so methods of control in experimental research. So a research design can lack a comparison group, and it can assess progress by comparing a treatment group to a baseline score. A while ago when I said instead of having two different groups, we can compare that group to itself. So if we did that, we would take a baseline score and then we would compare the outcome score with the baseline to find out, how do they compare? Was there improvement? Did it get worse? Did it get better? That kind of thing. When there's not a comparison group, it is considered a pre-experimental design. So the far left in the last table we looked at. So there is a risk in this design because there's no manipulation of a variable. So the independent variable may not be responsible for the change in the dependent variable. We don't really know that. We can't say that for sure. All right, so random assignment. Another method of control is random assignment. And random assignment means that a participant is equally likely to be assigned to either the treatment group, the control group, or the comparison group. It helps ensure that the experiment is valid. It protects against selection bias because you have an equal chance of being placed in one of the three groups. It protects against the influence of extraneous variables. One of those things that aren't being studied, but they could affect the outcome. I think we just talked about that or just mentioned it in the slide before. All right, in social science, we've talked about this in other chapters. It's really common to look at independent variables that we can't manipulate. When this says, like gender, when comparison groups are used without random assignment, we always place that under quasi-experimental. So if we're not assigning this person to a group, in other words, we're selecting, then it is quasi-experimental, falls under the middle category per the table that we looked at earlier. Controlling for participant group equivalency increases research validity. So what we want to do is we want to make sure if we're selecting for a variable instead of randomly assigning, that we have groups that are more or less equal in the comparison group, the control group, and the treatment group, if we have all three groups, that is. All right, so we have between groups models where the outcomes are compared between two or more groups. And then we have within groups model where we have a single group and it's measured, our outcomes are measured across time. So we can use two treatments, 3 treatments, 4 treatments with the same group. All right, between group. If we have a between groups design, the effect of the independent variable on the dependent variables based on the examination of group differences. So we're going to look at the difference between group 1 and group 2, and if the difference is statistically significant, then yay, we found something. If it's not, we found something too, but we haven't found anything that's hugely significant. Okay, so in a true experimental design, one group receives the treatment or the intervention, which is the treatment group, and the comparison group or the control group typically experiences no treatment. Typically, because the control group does also sometimes have a treatment. I'm doing air quotes here with my fingers. You remember earlier when we talked about, I forget what chapter it was, last chapter I think, maybe 4 or 5, we talked about how in medical interventions, if we have a control group, we're going to give that control group a treatment. It's just not the same treatment as what it is that we're giving the experimental group. All right, we have post-test only models. And in a post-test only model, participants are randomly assigned to a treatment group and a control group. The treatment group receives an intervention, the control group does not. And then we measure to determine the effect of the intervention by comparing the scores of the treatment group and the control group. All right, in a post-test only model, the design is really easy to implement. Random assignment is really important because we want to make sure that there is equality between the groups at the beginning, because if there's not equality at the beginning, we can't really trust the results at the end. So the caveat is, without a pretest at the onset, we can't know for certain that the groups were equal to begin with, but by random assignment, we will make that assumption. All right, so then we have pretest, post-test control group model. And in this model, participants are randomly assigned to either the treatment group or the control group. And then a quantitative measure is used to determine the effect of the intervention, just the same as the other. Both groups receive a pretest, and then the treatment group receives an intervention. Then we give both of them the post-test, and then we examine the degree of the effect of the intervention. And we know at this point that both groups were started out in the same place because we did a pretest, and we can compare, were they more or less the same? So now we know it was the independent variable that created change if there was a change created. All right, and I just said this. There's assurance of equality at the onset. The design is susceptible to testing effects. So if we're giving a pretest, the pretest itself can impact the outcome. So even though we're assuring equality of the groups, we've now introduced something else that could influence the outcome of the study. All right, so we have something called a Solomon four-group. And hang on one second here. What is going on? Okay, sorry about that. So in a Solomon four-group design, we eliminate some of the issues with knowing that we're ensuring that we have equality at the beginning, but we're also eliminating the impact, or we can account for any impact of the pretest. So in this slide, what you see is you see random assignment here. We have four groups. That's why it's called a Solomon four-group. So we have individuals that are randomly assigned to each of these four groups, is what the R is here. It tells you down below. Then we have two of the groups that are pretested here. And then we have two groups that are not pretested. All right. So then we have the interventions occurring here, and this group are getting the same intervention, and this group are getting the same intervention. And then at the end, we do a post-test. And this way, we can account for the intervention if when we compare all of these four groups, we can eliminate the impact of the pretest. And we know that because we randomly assigned that there was equality at the beginning. We did two pretests, but we also eliminated the effects of the pretest, or we can account for that. So this Solomon four-group is a really well-designed experiment. And my slides are not wanting to go forward. All right. So some of the strengths and weaknesses. So the strengths are in green, the weaknesses are in orange for caution. So a strength, we know that we've got equivalent groups at the onset. The strength of design is that it assures the equality of the groups. The researcher can determine whether or not the administration of the pretest affected the change in the dependent variable, or whether it was the intervention. But if we have four groups, we need a large sample size, and that can be expensive. It can also involve more time for analysis, and the analysis just got a lot more complex. All right, so factorial designs. Factorial designs are an additional element to the between groups design. It changes the design studies the change, in the dependent variable across two or more independent variables. So if we have two independent variables and a dependent variable, so let's say we want to study the impact of, smoking and weight on cancer or health, we could say the development of cancer, but let's say just health. So if we have two independent variables, we could have smoking and we could have weight, and the dependent variable then would be health. So because we have more than one independent variable and we're trying to look at both independent variables at the same time, the analysis is going to be really complex, and the results might not generalize across both independent variables. So what do we do? How do we figure this out? So if the results are not generalized to both independent variables, that's known as something called an interaction effect. It's the interaction effect that creates the outcome, not necessarily one independent variable or the other independent variable. So factorial designs can be applied to any of the experimental designs, and it gains more information because we're looking at more than one independent variable. The addition of other independent variables, it demands a representative sample for each treatment group and each control group. All right, so in factorial design, we've already said two or more independent variables, at least one dependent variable. We have a 2x2 factorial design, which shows us 4 cells. We're going to look at that, I think, in the next slide. We have, let's say we have 2 types of factors, and for this example, we're going to use methods of instruction. And each of those methods of instruction has 2 levels. So we're going to look at methods of instruction, and the methods of instruction we're going to look at are traditional and innovative. So let's look at the next slide. So if we were doing this, we would look at, it would look something like this. That is not the right slide. Hang on here. Oh, yes it is. All right, so the method here would be traditional, would be 1, and what would we call the other one? Innovative. I want to say newfangled. Innovative is method 2. And then we have small class, and here we have a large class. So we're going to use the traditional method with a small class and large class, and we're going to use the innovative method with a small class and a large class. And then we get something that sort of, it looks like this. So if we put in our data, it might come out looking something like this. And we could do a descriptive statistic, and we could ask for a graph, and it would give us maybe something that looked like this, or it might give us something that looks like this. And this shows us that there's an interaction effect. It's very obvious in a graph because the lines cross, right? So if the lines cross, we can look at that and say it's actually the combination of 2 things that are creating this effect. That gives us more information than what we would have if we only looked at one independent variable. All right, so up here, no interaction effect. Down here, our data set's different, obviously, and there is an interaction effect. All right. All right. So within groups, change does not occur only because of exposure to an independent variable. Change can also occur across time. So if we have one group and we're looking at this independent variable and we're measuring the change over time, we're going to pick up some change just because time has passed. So within group design, it's used when change in the dependent variable in a group is measured across time where participants are exposed to 2 or more treatments simultaneously, and the outcome is evaluated across time. So this is a within group design. So remember we talked about the one-shot deal earlier? So this is what that would look like. Here's our treatment, and here is our observation, which is our dependent variable. This is our independent variable. So weakness, we don't have any control, no control group at all. We really don't have any way of knowing if the results we've got are due to the treatment. We don't know. So if we wish to see if a new textbook increases student interest in our course, we could do this. But how do we really know what we've got? Because we don't really know what the level of interest was for people who didn't have the new textbook. Okay, so one of the things we can do is we can add a pretest. So this is one group, pretest, post-test design. So here we do the pretest, the treatment, and then post-test. So we are not controlling any of the threats to internal validity that could explain the results of the post-test. In other words, over time, we might have got more mature, or there could have been other things. So if we want to assess the effects of weekly counseling sessions on the attitudes of identified bullies in school, well, if we wanted to do that, would we do pre-test, treatment, post-test? Well, we could. That would be really difficult to know. It would be really difficult to know if there were other intervening factors, though, because we would know what the bully's attitude was before. We would apply the treatment. We could measure the bully's attitudes afterwards. But what if, they just matured more during that school year, and it was maturity, getting older or whatever, that was responsible for this change and not the treatment. So we don't have a control group. We don't really have any way to know. All right, so we're going to talk about crossover design for a minute. So in a crossover design, the effect of two treatments can be observed across a single group, sort of like we just saw in the one-shot deal with pre-test, post-test, but a little bit different. We're going to look at that. The researcher can track progress across time and differences assessed by comparing observations. The order effect of the treatment results in the outcomes being between treatments being incomparable. So if we have, say we're doing two types of intervention, the order that we're doing the intervention in actually can have an effect on the outcome. So in a crossover design, we want to try to eliminate that. So this is sort of what a crossover design looks like. We have here our first treatment, we have our observation, and then we have this period of time here in between the brackets, which can be referred to as a washout period. And what we're hoping is that during this washout period that our participants forget that this happened. And then we do the second treatment, and then we do a second observation, and time goes on. All right, so if we were just doing, if we were doing this, we look at our data, we see what we got. Well, now, let's see. I thought the next slide. All right, I'm going to go back to this for just a minute because you can balance this by, you would have another row down here, and in the second row, you would have another group. You would have the second treatment would actually be first, observation, washout period, and then the first treatment would occur here, and then observation. And then we want to compare the outcome of this group with the outcome of this group to make sure that it wasn't just the order of the treatment that created any of the effects. All right, and that's called counterbalancing. All right, so in a Latin square is an appropriate design to use if we have 3 or more treatments. All right, it can be very complex. The more groups that we have to divide people into, the bigger the sample that we need. All right, so instead of participants being randomly assigned to treatment, participants are randomly assigned to a sequence of treatments. The sequence effect, it's not entirely eliminated, but statistical power is increased because the order effects are accounted for. And this is just a more complex design than the crossover design that I just explained. All right, so for example, suppose a researcher wants to determine the effects of 4 technological innovations in teaching social science taught by 4 professors to 4 groups of students. So we get a lot of moving parts here, right? We got four teaching methods, we got 4 professors, and we got 4 groups of students. So each professor is required to use each method of reward. The first treatment combination consists of a teacher, a technology, a professor, and a student. So T1 is the technology, P is the professor, S is the student. The second combination, and here it is, we have a technology, we have a professor, and we have a student. So we're still, let's see, so forth and so on. Now we're going to look here at the next slide, and this is what this would look like. So here's our technology 1, 2, 3, 4. Here's our professor 1, 2, 3, 4. And these are our students. So Professor 1 using technology 1, Professor 1 using technology 2, and our students are populated throughout this grid. All right, now notice that S4 is the diagonal in a square, and it appears in each position from the first position to the 4th method, right here where we see the line. Whoops. All right. So in order to do a statistical analysis on this data, we would use an ANOVA because we want to determine the significant difference on the effectiveness of the 4 teaching innovations taught by the 4 different professors. And we would have a computer do that for us. All right, then we have something called split plot. So if you want to combine a between groups and a within groups method, then a split plot might be what you want to go for. So in a split plot, it combines aspects of a repeated measure design and a factorial design. So a participant is exposed to all aspects of the within group variable, but only one level of the independent variable. Now, we're going to have an example of this though. All right. So an advantage is a researcher can track changes over time and compare various groups with respect to change over time. Disadvantage, the researcher can't be certain that the independent variable is the reason for group differences, as some variables can't be randomly assigned. And another disadvantage, the design can detect group differences, but a cause and effect relationship can't be assumed. All right, so here we have a split plot. And I think this is interesting because I found it a lot easier to remember split plot whenever I found out that split plot actually comes from agriculture, and folks in agriculture are the ones who actually came up with this type of research. And it makes sense if you think about it. So I've pulled this as an example just to sort of say true to the split plot roots. All right, so we have two factors of interest. So let's say the first one is irrigation, and we have two levels of irrigation. And the second factor is fertilizer, and we have two levels of fertilizer. So we cross those two factors at two different levels to form a factorial design. And you can see that in the little tables below. All right, so a fertilizer treatment can be easily applied on a small scale. Irrigation treatment's problematic. Irrigating one plot may influence neighboring plots, and furthermore, irrigation equipment is most efficiently used on a large area. So, the investigators want to apply the irrigation to a large or a whole plot, and then split the whole plot into two smaller subplots in which they apply the fertilizer treatment levels. Okay, so we've got a big field, right? And here's our big field. You see it. So in the first step down here, the first step, the levels of irrigation treatment are applied to 4 experimental fields to end up with 2 replications. And you can see this, field 1, field 2, field 3, field 4. And you've got irrigation level 1 and irrigation level 2. And then down at the bottom, you've got overlaid on top of that is the fertilizer. So fertilizer is B, and we have levels 1 and levels 2. All right, so I think that makes perfect sense whenever you can picture sort of that in your head. Whenever we talk about split plot in the abstract, I think it's difficult to understand. But when we think about, okay, it's actually a plot of land, or it could be a plot of land, and we're splitting it into different pieces and doing different things with it, it becomes much more concrete and easier to understand. All right, experimental validity. There are 2 types. There's internal and there's external. So internal, the extent to which the independent variable truly is responsible for the change in the dependent variable. And then the external validity is to the extent to which the study can be generalized to other settings and other populations. Threats to our experimental validity: and any variable that's not controlled can affect the outcome and threaten internal validity. And it is not possible to control for every extraneous variable. But if we have a true experimental design, we are exerting the most control, and that minimizes the effects of extraneous variables the most. All right, all of these are threats to internal validity. These are talked about in your book at some length. I'm not going to go over each one of them because I think it's something that you can read for yourself. But just know that there's a lot of things that we have to pay close attention to and try to eliminate as far as internal validity. And then threats to external validity. We've talked about some of these already. But again, these are all discussed in your book. You should be aware of which ones are internal and which ones are external. All right, so how does it apply to counseling, or why is this important to us as counselors? Well, one, we have an ethical responsibility to be able to understand research and to be able to apply it correctly to our practice. So if counselors are using experimental research designs to evaluate their practices, then they're in this sort of unique position to give voice and representation to important therapeutic work that's done with their client populations. And no matter what that is, if you're specializing in depression or if you're specializing in PTSD, if you are doing research in your practice, then you can have sort of this voice on a larger stage. Good research also helps promote the legitimacy of counseling practice. And that ends Chapter 6.